Shall we talk about ints? Who uses ints?
I only use Float 64.
You only
no matter what it is.
Yeah, because you're always on point, or something like
Nicely done.
Something
that's
like
the
that.
first good joke you've made today, Matt.
Just today.
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. Our feature flags are powered by LaunchDarkly. Check them out at launchdarkly.com. And we're hosted on Linode Cloud servers. Get $100 in hosting credit at linode.com/changelog. What's up, Gophers? Our friends over Gravitational made a big transition at the end of 2020 to rebrand as Teleport and shared a new product announcement to showcase the direction they're taking. Teleport is operating from a vision of being able to run and access software anywhere in a secure and compliant manner, something they call environment-free computing. With Teleport, engineering teams can quickly access any resource anywhere using a unified access plane that consolidates access controls and auditing across all environments, infrastructure, applications, as well as data. Teleport server access lets you SSH securely into Linux servers and smart devices with a complete audit trail. Teleport Kubernetes access lets you access Kubernetes clusters securely with complete visibility to access and behavior. And finally, Teleport application access lets you access web apps running behind NAT and firewalls with security and compliance. Try Teleport today in the cloud, self-hosted, or open source. Head to goteleport.com to learn more and get started. Again, goteleport.com.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. If you're following Go Time FM on Twitter, then you already know that your chance to win Mark Bates' Raspberry Pi 400 is on and poppin'. There are 3 ways to enter. Check the link in your show notes to read all about it. Okay, let's do this. Here we go.
Hello and welcome to Go Time. I'm Matt Ryer, and today we're talking about Go language proposals. Go is open source, so you can open issues and make proposals. And sometimes people do that, and then sometimes they end up in the language itself. So we're going to learn a bit about that process and take a look at some of our favourite proposals. Joining me today, Johnny Borsico's back. Hello, Johnny.
Hello.
Welcome back, sir. It's been a while.
Yeah, it's been a while. Although I was on last week's episode, you weren't around. But
yes,
for you, I'm back. Yes, I'm back.
Yes, you're new to me.
I'm new to you.
The listener's probably sick of you, but to me, I'm not.
Fixture on the wall, kind
of. No, not really. It doesn't happen that quickly. 2 or 3 episodes. We're also joined by Chris Brando. Hello, Chris. Welcome back.
Hello. Glad to be back.
How have you been?
Been well. You know, getting the new year started. Almost done with January.
Mm-hmm. Yeah. Same for us, actually. And same for Daniel, who's joined us also. Daniel Marty, welcome back, sir.
Hi, happy to be back.
Thanks for coming back. Thanks for accepting our invitation. Maybe you could just start off by telling us what's the process behind a proposal? What's the usual sort of flow? How do they come about and what happens to them?
So it's been a process that has iterated quite a lot in the past few years. So initially it was, as you can imagine with any open source project, people would open issues and be like, hey, please do X or Y. With language features, it was kind of messy because sometimes you would get 2 lines of somebody saying, hey, add generics, that kind of thing. So over time, it became more formal. So for really fancy changes like generics or error checking, there's a formal process where you have to write a document and sort of write an experimental implementation of your language change. But most changes that get proposed are smaller. So instead, there's a small template that you have to fill. And I think that's what most people end up doing.
Right. And then what happens once they're out? We're talking open source, aren't we? So this is available for everyone to look at.
Right. So it's a bit tricky because it's hard for the team to prioritize because Something they could do is, for example, go from oldest to newest, but there's such a large backlog, and some proposals are much more complex and large than others. So if you do them exclusively by creation time, I don't think you would get very far. You would get stuck pretty quickly. So they do a mix of like easy ones and ones that they agree with, sort of. And then over time, they tend to get to most of them. And I think they meet about once a week, and they sort of consider about a dozen proposals per week.
Right, yeah. So that's amazing, really. And to think of like all the different possible things you could change in Go. Of course, there are going to be a lot of those proposals because, sometimes it comes down to personal taste. Sometimes people think of things that perhaps in this one specific case, it would be a great feature, but maybe it doesn't fit in other situations. So it is kind of a difficult thing to do, I think, isn't it? To balance that. And like you say, some easy ones as well. And so, of course, the difficulty of implementing and maintaining features as well becomes the thing. You must have to kind of consider all that stuff.
Yeah, and I think the template is sort of the first filter nowadays, which I think is pretty well designed. It's pretty long, so I'm not going to read the whole thing, but some bits are pretty interesting. There's stuff like, how long have you been using Go for? Or who would this change help, such as only researchers, or maybe people who do 3D games? And other questions like, has this been proposed before? And if so, how is this different? Or things like, is this backwards compatible with existing Go programs? Because sometimes if the answer to a lot of these questions is not what you're after, the change is most likely not a good idea.
And you can sense that they're encoding in those questions a way to make sure you've checked to see if there's already a proposal that's been made for this. Because actually GitHub issues isn't probably the best way to solve this problem. So I imagine there's a lot of duplication and things like that.
Yeah, and I actually find GitHub search not very good. It's almost like a keyword substring search. So I actually use Google to search for Golang issues because there's 50,000 of them. So it's the only way, really.
That's a good tip. How do you do it? Any special way?
So you can filter by site. So I filter by github.com/golang/go/issues and then whatever keywords. And it mostly works. But it's especially better than GitHub search in terms of relevance because, if you didn't get exactly the right keyword, GitHub might not even show the issue at all, that kind of thing.
Okay, so maybe we could have a look at some of the proposals that are out there. Some really interesting ones. And we're not going to pick any that are currently underway. Is that what we said? Although I think we've added a few extras since then, haven't we? Maybe.
Yeah.
Yeah.
At least what I try to do when picking these is avoid the big issues like generics and error handling because I feel like those are too controversial and already, there's a lot of material on them. Yeah. And we also picked proposals that are still being considered, but that haven't been accepted yet. So it's still stuff that's a bit up in the air.
By the way, though, Daniel, nothing's too controversial for this show. We'll go anywhere. And that's a promise.
Fair enough.
Yeah. So one of the first ones on the list we have is this. This is a really interesting one. It's issue 21670, which makes me feel like I'm in Star Trek by saying that. It is have functions auto-implement interfaces with only a single method of that same signature. So this is essentially how we have handle func, which is a function type that implements the handler interface. And you have to explicitly say that in the code at the moment. It's quite a short amount of code usually because all you're doing is creating a method that then calls itself. So it's not too difficult to do, but this proposal is about making it automatic. So given a handler interface that has a serve HTTP method, you wouldn't ever have to have a handler func type. You could always just make a func that matches that single method. It would only work for single method interfaces, of course. What do we think about it? Daniel, what do you think about that one?
Somebody made a comment in this proposal, which I think was a good point, which is that in Go, you can go from a method to a function by using a method value. So we've got a variable of type bytes.buffer, and you name it buff. You can do buff.write, and that is a function. So you can go from the method to the function, but you cannot go back, if that makes sense. If you have a function, you cannot easily say, okay, now use it as a method. You have to statically define a new type to use that function. So in a way, this would make the language more consistent, but then the question is, how often does this come up? NetHTTP is a good example, but I struggle to think of more than like 4 examples.
Well, from the standard library, maybe, but I love that pattern from that. I copied it from the handler func. So whenever I see opportunities to use that, I do. And there are often opportunities. There are lots of times when, especially when you're building something new, there is a new abstraction somewhere, but you're not sure about it, or all you really need is just one thing from it. So inevitably it ends up being a single method. So I do a lot of homegrown single method interfaces, if you like, and usually have a func version of them. In fact, sometimes I only just have the func thing too.
I think maybe the main argument against this proposal is that you could argue that an interface is not defined only by the signature of its methods, or in this case, a single method, but also the name of the method. So for example, is any function that looks like a read really a read? It could do something entirely different, and it might match the reader interface by accident. I'm not sure that this would be a problem that happens often in practice, but it does sort of break Go's explicitness a little bit.
That's true, yeah. Because you're no longer dealing with that interface type, and it's not explicit. That's a good point. Chris, what are your thoughts?
I guess I have a clarifying question here. So this is like when you pass it into, like pass a function into something that takes the interface, it would just be like, oh, this satisfies this interface. I think in that case, like, I generally like this because I feel like when you do have a function you just want to pass it in, it's kind of annoying to have to wrap it in that, like, oh, http.handler func, here's my function. Just like adds a bit of verbosity when it's already kind of obvious what it is. I'm sure there's other use cases where it would be used, but from that perspective, it feels like that is something good about the language that would cut down on verbosity. Because I feel like Go is often a lot about just cutting down on verbosity overall.
Yeah, well, that's interesting because to Daniel's point, makes quite an interesting point. If somebody made an interface that was just returned a string, say that it was called identifier and it had an ID string method, you could easily have a function that returned a string and passing that in. I was just wondering about that case, about accidentally implementing an interface. But you're passing a function into a thing. So you're really aware of what you're doing at that point, aren't you? In fact, you're probably making the function anonymously, aren't you? So that you're doing it in line right there. So I feel like that I can't imagine that becoming a problem.
I think in some cases, but I think you could also just have package level functions that you want to use as an interface. And I think as far as like confusing interfaces or like accidentally implementing them, I think the only one that I've consistently accidentally implemented is Stringer, which I just think is an issue with Stringer overall that we're probably never going to get away from. Of just like, oh yeah, like this thing will always print out whatever this method puts out if you like pass it into fumped, any of the fumped functions, because it implements Stringer. But I've never really had that issue with like any other interface of like just accidentally implementing it.
Yeah, I think I'm probably the same. I think, yeah. Johnny Borsico, what do you think about this idea of having functions automatically kind of magically implement an expected interface?
I have somewhat of an allergic reaction to magic, so
yeah,
I tend to prefer.
It's all the glitter gets in your nose, doesn't it? Yeah,
I know. Yeah, it just gets everywhere. I start sneezing and coughing and all that stuff. So it's kind of like
beautiful sneezes, though, like fireworks.
Yeah, exactly. I mean, I kind of see the intent behind it, and it's one of those things where it's sort of adding a layer that I'm not super like. Well, I don't want to say I'm uncomfortable with it. It solves a problem I don't find myself having very often. So I don't mind sort of that explicitness. So I don't know. I'm on the fence about this one. I don't think I'd be like pushing for it very hard. That's just my
right. No thumbs up on the GitHub issue from you.
No.
Okay, let's move on. See if any of these we can get some love for. Have you seen this one? It's issue 43557, and this is about function values as iterators. So this is a way to let you implement a type that will work with the range for loop, and it does it by having an inter method which returns a function which will get the next item. So you kind of relies on closures to keep the state, and then obviously if it's a method, which it would be from a type, it can use data from that type when kind of it's called. So it can return like the next item in the list or whatever it's doing. How do you feel about this one?
I feel like that's a carryover from other languages. I've used this sort of pattern in Java and stuff like that, and it's fine. Again, I tend to be at first, my default stance with sort of improvements like this to the language tends to be sort of, what is it that the language does now that this could improve? So this adds another way, a different way of sort of doing your iteration. And I don't have a need for that. Again, I don't want to be the curmudgeon in the corner saying no to everything, right? But like to me, like if you're going to improve the languages in some way, like I don't want like half a dozen ways to do the same thing, right? And Go, like the fact that Go only has 4 for looping. I mean, to me, that was like, at first I was like, wow, really? Like, aren't you going to be missing some things and keywords, some constructs, whatever it is? And then you sit down and you start using it like, oh, okay, I guess, yeah, I don't need much else. I can do all the things that I need. So to me, this is another one of those.
Well, this doesn't add a new way to loop over. It just means you can write types that work with the current 4 range thing, right? I mean, the way you have to do it at the moment is either you build your own API, you have your own methods and you just implement your own iterator, or you do something, if it's small enough data, you'll just like maybe create a slice, have a method that creates a slice, and then that slice can be easily ranged over by the 4 block thing. That's right, isn't it, Daniel?
Yeah.
Thought I saw you shaking your head in my periphery.
I was thinking that I've actually seen some people use channels for this use case, and that is avoiding the boilerplate with next, done, and so on, that kind of method interface. And it kind of works, but channels are also like the biggest foot gun in the entire Go language. So I really don't like when people use channels for that. And they also have their own inherent overhead, right? So a channel is an allocation, and it also means that there has to be a different Go routine on the other side sending you stuff. And how do you signal that you're done and that kind of thing? So I'm kind of with Johnny on this, that I don't think this is a big enough problem to require a language feature. But at the same time, out of all the solutions that I've seen to like implement custom ranging, I feel like this is the simplest and nicest. I wouldn't oppose it, but...
Yeah, so you wouldn't thumbs down on the GitHub repo, on the GitHub issue. I see, I'm with you on that. Of these solutions, this is probably my favorite because I like the fact, I mean, it is a little bit complicated because it's a method that returns a function. And then you have to know about closures in order to make that work properly. But it is very neat to have all your iteration code in just one method. And then the fact that you're able to use it as a normal type is kind of quite nice. The only thing is it hurts readability potentially, because at the moment when you see a range block, you know that is a map or a slice or an array. Like, you know that isn't anything more, and it's not doing much more work, is it? Whereas if you've got your own iterator implemented, that could be doing expensive things, and that wouldn't be very clear straight from just looking at that code.
And you're also relying at that point on sort of the convention, right, of the naming, and basically whenever you see that, you're like, oh yeah, the iterator pattern. You're like, okay, it's like you have to kind of trust, right? Obviously, you can always go take a look at the code, hopefully. But to me, again, the explicitness of my iteration matters to me, I guess. But I mean, this is nice. I mean, as presented, it is a nice idea. I'm not gonna, beat down on it. Is it worth the trade-off for me? This is another one where I'm like, no, I can't see it.
I think I want to like this. Like, I like the idea, but I think the big thing for me about it is that, like, slices and maps are like known quantities, right? We can get the length, we know how long they are. With most other types of iterators, you usually have some error that might happen, right? If you're getting something from a database or you're getting something from somewhere else, and there's not really anything in here about how you would do error handling. That's like one of the things I like about kind of the iterator pattern that I've fallen into a lot, which looks a lot like, I think like db.rows does this, where you just have like .next that returns a bool, and then inside of it, you can actually get the value, and then you have an error afterward if the bool returns false. And then it kind of has this like neatly packaged way of handling iteration. Cause yeah, I just think like this would definitely, I think, get abused in some ways and lead to people just not recognizing that they need to handle errors, or like call another method to get the error when they get false back. So I think this is like, it adds a little bit of nicety, but I think it would become like a giant foot gun for API designers.
Very interesting. Cool.
One thing I want to come back to, Daniel, is that you said channels are a foot gun. I'm considering that an unpopular opinion, but we'll swing back to that one later. Just making a mental note, a verbal mental note.
Sounded like a verbal mental threat. More than just a note.
And I was about to also bring up something about, ranges being simple nowadays, because they're not really. You can range over a channel and that could block forever, basically. Or you could range over, for example, a slice where each element takes a gigabyte in memory, and then you have to copy that in every iteration, and that could take a long time.
Right.
So I think ranges are already kind of confusing. This would maybe make them more confusing, but it's not binary, like suddenly they become bad.
Hey Gophers, this episode is brought to you by our friends at LaunchDarkly. Feature management for the modern enterprise, power experimentation and production. Here's how it works. LaunchDarkly enables development and operation teams to deploy code at any time, even if a feature isn't ready to be released to users. Wrapping code with feature flags gives you the safety to test new features and infrastructure in your production environments without impacting the wrong end users. When you're ready to release, more widely simply update the feature flag, and the changes are made instantaneously by the real-time streaming architecture. Eliminate risk, deliver value. Get started for free today at launchdarkly.com. Again, launchdarkly.com.
It's time to move on to the next proposal. Daniel, do you want to tell us about this next one?
Yeah, so this next one is pretty easy to understand, I think. It's essentially type inference for when you use make and new. So you can use make or new to, for example, make to create a new map with some capacity, or new to allocate a pointer to an int, or a boolean or whatever you want. And that is fine, but quite a lot of the times when you use make or new, you're assigning that to something that already has a type, like a field, like a struct field. So in those cases, you have to repeat the type, or even worse, you have to remember what the type was to then copy and paste it or write it again manually. So this is a small language change to say only within those two built-in functions, infer the type if, for example, it's missing. That would be like neo syntax.
And this is number 34515 in the GitHub issues in the Go repo if you want to follow along at home. Okay, what do we think about this one then? Chris, have you got any thoughts?
I like it. I'm kind of thinking about when I write test code, I sometimes like to have lots of anonymous structs and anonymous things, and it'd be a little bit easier to make a map if it already has the type there, and it cut down on the code a little bit. I don't know how I feel about the kind of empty or whatever the syntax we come up with, just having something be make. I think I'd take a while for me to get used to that, since I'm so used to seeing a type in there. But I think overall, it could be a benefit to the language and make things a little bit less verbose in obvious situations. So overall, I think I'm a general thumbs up, but cautious.
Yeah, general thumbs up. Ian Lance Taylor actually recommended using the 3 dots again inside the make to indicate, infer the type, because it's the same. That's what we mean inside, well, for lengths of arrays, and also if we're doing other times, I can't remember. So yeah, I'm with you actually. I quite like this one too. I feel like you don't get really any benefit from repeating it, I suppose. And so maybe that's the argument though. Would there be a benefit if they're separated, those two types? Would you lose something? Would you have to then go back to the type?
I like that one. Of the ones so far, this was probably my favorite one. I could see using it. What we settle on in terms of how to indicate hey, go, we've already specified the type, go figure it out, whether it's a 3 dot or the original post was proposing a type of keyword, which would definitely get abused everywhere. Yeah, I could definitely see that, because you've already specified the information. I mean, the language can infer the type. So it's like saving a few keystrokes. I mean, of the bunch we've seen so far, this is probably the one I could see using. Like to borrow Chris's opinion, they would take me a little bit of getting used to, because I'm not used to. I'm always used to specify my types, but I don't know. I could see myself like getting used to it.
Yeah.
I think like is said in the proposal, make and new are kind of weird functions anyway, since they take like a type name, whereas most other things in the language don't take type names, so they're already a bit like different and weird.
Yeah, why are they different? Why couldn't that be one keyword?
Yeah. And I was actually going to go in that direction. I find make and new to be too special, and this would make them further special. Like, for example, if people currently have composite literals for like maps or something else, they might switch them over to use make just so that they could get type inference. And I find that kind of weird. So I would rather almost see make and new gone. And, well, make wouldn't be gone for good because it can still be useful to, for example, specify the capacity and that kind of thing. But in most cases, you don't need to specify. You just want to create a new thing.
Yeah.
So I would rather see composite literals become more powerful.
Are auto kind of instantiating maps such a big problem? I mean, I love how the append key built-in function will make the slice if it's not already there. If it's nil, or if it's, you've just declared it, then it will make it when you put the first item in. It will set things up. Could we not also have maps that behave that way, or is it just that way because it's sort of would be too magic?
If you had that, though, anytime you want to assign to a map, you'd have to like call a built-in function and reassign to the map, which would be, I guess it would be worse. I don't know.
Well, I mean, it could be, yes, but I was thinking the language would stay the same, but it would work. You'd be able to just, that as a core principle, not as a change, I suppose.
So like the compiler would be like, oh, this is a nil map. I'm going to instantiate it for you and then add this value or whatever.
Yeah, because that's really the experience we get with append. But that's not this proposal, by the way. But I was just saying, I always thought it would have been all right.
I definitely agree with Daniel, though, on like how make and new are kind of weird, especially when you're first learning the language and you're like, oh, I want to make a map or I want to make a slice. And you think like, oh, I'll use new. I'm going to make new other things. So I should make new here. And it's like, no, new is not what you want at all when you make a map or a slice. And I think that's like something that trips people up a lot. And you just like kind of got to get used to it. So yeah, I think like if there was a way to like reduce down what you used make and new for, I think that would be good.
Yeah.
Because a lot of the time it's just better to just like do the kind of instantiation without using the built-ins. Unless you really do want to have that capacity or you want to specify the length and don't want to type a bunch of empty values in a slice or something like that.
It is awkward explaining new to a Go beginner when to use it, when not to use it. It also like usually the conversation, well, is that like a constructor kind of thing? Like, can I use it to like initialize a new thing? And how does that work? And I can only use make in certain cases, like with channels and other places. It becomes very sort of confusing, but I don't think that's a bad thing, honestly. I think that's just Go. Once you learn how Go works, you kind of get over those minor issues. I call them minor, but again, I'm speaking for somebody who's been doing this for a little while, so my opinion is going to be very different from somebody who's approaching it. And I'll admit that, like it's the curse of those who are experienced, right? You no longer see the problems beginners have, and I totally own up to that.
Yeah, I think that's fine. I like the curly brace to create new things because it's the same for maps and slices and structs and stuff. So you can yourself choose to just do it one way. And so I would actually be happy with just that way. I think we should just only have that.
Except basic types.
Right. Yes. Also zero value types, I think, are also quite nice. So the fact that works, I think, is, it's kind of good. You can call methods on nil types, and it isn't always a disaster. Anything else on this? Then we shall move forward. Sorry if that was too loud.
Jared's going to have words with you.
Yeah. Someone's got a mouse wheel because I've been listening and you've done about 6 miles so far. Calling anyone out, someone's got a mouse wheel, is all I'm saying.
Might have been
a
me.
wheel on a mouse. It's a wheel on a mouse. It doesn't matter. I'm just saying I can hear a mouse wheel going. It's been about 6 miles. Been keeping track of my Apple Watch. So, okay. The next proposal then is called lazy values. Daniel, what's this one?
So this is proposal number 37739, if anybody wants to check it out. And it's essentially trying to solve the problem that, for example, if you've got some verbose logging lines and you are logging some things that might be expensive to calculate, to evaluate, such as, give me the string of something, or give me the length of some very large decentralized data structure or something like that. And the thing is, yes, the log verbose function can do nothing if the verbose logging is not enabled, but those parameters, those arguments have to be calculated anyway, because it's still a function call. And you can wrap the whole function call in an if statement, but that's very verbose in itself. So what this proposal says is essentially, what if we have a sort of generic interface that has a method called eval to evaluate into some type t, and then when you pass that onto a function which is designed to take lazy values, then it's going to evaluate that lazy value as it needs it, but not otherwise.
Yeah, so essentially then you can pass functions into other functions and other types, and it'll only be called when they're used inside that function body. Is that right?
Yeah, pretty much. And you could do this today with like interface types or functions, passing functions. But I think this is more about making it more of a proper language feature that people should be using for this kind of thing.
Yes. Well, often lazy loading is a good thing to do in code for various reasons. Chris, how do you feel about it being an actual language feature?
I guess I'm kind of on the fence with it. I can see where and how it would be useful. I think my only concern would be like getting the API right. And then also, or I guess I have two concerns then. I think also how it can be abused and helping to make sure that it's not abused to like kind of make egregious Go code. I think like channels always come to my mind when I think about that, of how people just like really abuse channels in bad ways just because they're there and channels are a feature of the language. I could see people perhaps being like, oh, we have this like lazy evaluation. I know how lazy evaluation works in language X, so I'm just going to do what I do in language X, even if there's like a more idiomatic Go way to do it that has either better performance or more clarity or whatnot. But I think if we can, as a community, figure out how to like convey this is the kind of things you should be using lazy for and lazy evaluation for, then I think it could be a very useful feature in a wide range of software.
Yeah, you see, I've implemented almost this, but by using functions. So the idea is you've got some kind of loader and you just pass in the function and it works because it can also be the method of a type as well. So you can even have it in a kind of services or other higher level kind of object design situations as well. And so it's nice, you pass the function in and internally, depending on when you call it, if you even do, it only gets called at that point. The nice thing about doing it explicitly is you get to choose like arguments and things like this. Whereas this proposal, where it seems like almost it looks a bit like defer, how you're calling that method immediately. But I guess, it's kind of trade-offs and things. Johnny, did you have a chance to look at this one? This is the functions, lazy values.
Yeah, I didn't have enough time to sort of form an opinion of it on its face. It looks like an interesting idea. I just don't have an opinion on it.
Fair enough.
Somebody also left a counter proposal somewhere in the comments, essentially saying, if we made anonymous functions less verbose to write and use, then people would do what Matt said of using function parameters more often. And I think I agree with that.
Yeah, those function parameters are definitely worth a look, I would say. Okay, that's an interesting one. It's funny, seeing these proposals, they're sort of, a lot of them so far are solving real code problems that we've lived with for a while. So it's interesting to see the different kind of points of the life in a language. Because, of course, there have been language proposals all along, but these are interesting to see some of the level of these. Shall we talk about ints? Does anyone who uses ints in your programming life?
I only use Float 64.
You only do,
no matter what it is.
Yeah. because you're always on point, or something like that.
Nicely done.
Something
That's
like
the
that.
first good joke you've made today, Matt.
Just today.
Yeah, that's a compliment.
Ooh, it's a pylon. Daniel, it's your turn.
Oh, no, I was going to say a joke about Batman and, not a number.
Oh, yeah. Thank you for taking the heat off me and placing it rightly onto Batman and that not a number thing in JavaScript. They both deserve our. They both deserve our ire. Okay, let's talk about ints. There's a proposal to change an int to be arbitrary precision, which when you think about that, this is number 19623. That as a headline doesn't make much sense, but Daniel, perhaps you could explain this one to us.
Yeah, so to recap, Go has, for example, int32 and int64, which are fixed size. So, for example, in int32, you've got 32 bits. When you get to the maximum value, which is 2 to the power of 31 or whatever it is, if you go past that, then it overflows and it goes to the lowest negative value.
Right, so it wraps around.
Yeah.
Yeah, like Pac-Man. I think it's called that. If not, it should be. Go on, I'm just trying to make it clear for all levels, all abilities.
Yeah. So essentially, you don't have protection against that kind of error where it essentially loops around and goes back to the bottom. And then there's int, which doesn't have a fixed size. So on 64-bit computers, like most laptops and desktops these days, it's 64 bits. But on, for example, small routers, which might still be 32 bits, it's going to be 32 bits. And this causes some bugs in real programs because, for example, people might only test on 64-bit machines, and then their code might actually break on 32-bit machines with like regular workloads. So this proposal is essentially to say, no, the int type without a size never wraps around. It's essentially infinitely sized. And then it's up to the compiler to generate good code to implement that.
So would you be able to go beyond int64 with this proposal as well?
Yeah.
Well, it's getting more interesting. Although I've never needed numbers that big, but still, I want them.
It would be kind of like, I'm not sure if many of you have seen the package math/big, but it has a big.int in there, and that is arbitrary size. So you can store whatever number you want in there. So this is kind of like that, but in the language.
That is a big int. You can get some really big ints in that type.
I keep trying to squeeze that one in.
It's massive. You can't. It's a big int. What's the biggest int you've ever used, Chris? Be honest. Have you ever gone beyond int32?
I have written things that use int64, need to use int64 for various reasons. I do really, I like this proposal. I'd like it if we did have more arbitrary precision things in the language itself. Like the math.big package is a little difficult to use. And I think there's some interesting opportunities for having kind of good arbitrary arithmetic built into the language, right? Like adding arbitrarily big integers together, which I assume that would come with this if this proposal was accepted. I think the only maybe strange thing about this is if you were doing any bit shifting or using like an int as a bit mask, but you probably shouldn't have been doing that. So that's probably not an issue. But in general, I like this. I feel like the int type right now is kind of in this like useless space because it's like you can't really guarantee how large it's going to be if you're writing code that is cross-platform. So I think that kind of forces you to default to using like an int64 and int32 or a uint64 and a uint32. But I also think that it's good for kind of like if you're trying to specify a length or like kind of what Rob lays out in this proposal, I think that's good to know that like you won't overflow or you won't have that type of issue when it comes to specifying something. Or you won't, have the issue of it being only 32 bits and you have a really large thing and now you've run into this problem where your code just like isn't working and failing in a weird way.
Yeah. But what about the implications at runtime of this? Does this mean ints would be slower? Because there surely has to be some runtime element checking to see the size before you cross a threshold into needing bigger and bigger ints.
Yeah, and I think that's where people sort of wave their hands a little bit and say that modern computers are good enough at this stuff. On one hand, the compiler can be smart enough to, in some cases, realize that it doesn't need to check if something will overflow. For example, if you use an integer to range over a slice is never going to be too big to not fit in memory, so that's fine. And another case is if you cannot statically know that for sure, you can also say that modern CPUs are good enough at predicting branches and say, oh, this is basically never going to happen in practice, so the CPU is essentially not going to be any slower at executing this code. But those are the kind of things where you would have to actually experiment with this implementation and see.
Yeah. Good points. Anyone else want to say anything else about this one? I like the idea of just massive ints.
Just generally?
Yeah, you need it. I don't need it, but it's like whenever I buy a laptop, I always get the most RAM I can get. And honestly, I'll try and find reasons now to use up RAM. Like, if you've got any data you want me to store for you, just let me know. Send it over. I've got loads of RAM going to waste.
I do wonder as well if there's maybe a corollary proposal, and probably already exists, to have a float type in a language that is arbitrary precision. Because I feel like that could be useful for perhaps financial applications where you really need that arbitrary precision. Arbitrary precision. You can't use a float 64 for money. Please don't use a float 64 for money. That's a bad idea. And it's one of those things where I always when I go to use a float, I'm always oh yeah, float. And I'm oh no, it has to be float 32 or 64. I have to specify it. So I feel like adding that type there could also be useful if we're already going to add or change how int works and how uint works.
Does anybody know why we don't have that? I mean, we have it for ants. Why don't we have just a float? I don't know.
I think it's a carryover from C.
Okay.
Because C does have an int type, which is essentially just the machine size int, but it doesn't have the same for float. It only has, single and double precision. Let go.
Yeah, because an int's just a bit of memory, innit? It's just one bit of memory, not a bit. But the machine's 32-bit, so that's what it can move around fastest.
For those who are gonna be listening to the show, we're all making a face at Matt right now, shaking our heads,
Yeah. But they've already paid for my computer science course, so shut up. But no, I'm just saying, it's that reason what Daniel said.
And I feel like my overall stance on this is that I like the next proposal better, which kind of aims at the same problem. So maybe we should talk about that one.
This episode is brought to you by our friends at Equinix Metal, globally interconnected, fully automated bare metal. Equinix Metal gives you hardware at your fingertips with physical infrastructure at software speed. Accelerate your workloads with fully automated bare metal that's secure, powerful, and cost-effective. This is the promise of the cloud delivered on bare metal. Equinix Metal makes it easier than ever to take advantage of the unmatched global reach and connectivity ecosystem made possible by Equinix, which includes more than 220 data centers across 63 metros, making interconnection easy. And they're obsessed with making bare metal even more awesome. Seriously, check out these features. 60-second deploys, hourly pricing, a customer success team that engages over Slack, x86, Intel, AMD, and ARM, single tenant, NVMe and SSD storage, RESTful API, first-class DevOps integrations, Equinix Fabric integration, support for enterprise OSs and open-source Linux OSs, air-gapped installs without a public IP, no installed agent or keys, extensive open-source love and support, plus so much more. Visit info.equinixmetal.com/changelog. Get $500 in free credit to play with, plus a rad t-shirt. Again, info.equinixmetal.com/changelog.
So the next one talks about having new types that are stricter, right? So that you have, as well as an int, you'd have an oint, which is a kind of overflow int, or overflow protected, I guess. And it would panic if it was to overflow, right? So instead of just wrapping around like Pac-Man, it would be like if Pac-Man went off the screen and never came back, right?
Pretty much. And this is issue 30613, if anybody wants to check it out.
Yes. So are there people that struggle with numbers and them overflowing a lot, are there particular people that kind of programmers that struggle with this? Because I've never come across it.
So I'm going to bring up one case that's quite common with this kind of issue, overflows and underflows, that is. And it's when you implement codecs or things that have to encode or decode images, video, audio, that kind of thing. Because you can quite easily, like if you just write the code and you're not thinking about overflows and underflows, you're thinking about, inputs that might be like 1 kilobyte in size. But what if somebody feeds you like really, really large data or something that you didn't expect? And then suddenly one little loop that looked very honest and fine, it suddenly loops forever because it's overflowing and it's just looping and looping forever. And then suddenly your CPU is stuck.
Yeah. Why don't you just put it all into a big int? Okay, don't do that int idea. I won't teach computer science, don't worry. How do you feel about this then? I mean, I feel like, adding a new type like this definitely makes sense because it's completely backwards compatible. Anyone else have any strong feelings either way?
I feel like this is this would be a good addition, especially for like the smaller ones. Like I know I've sometimes written code that needs to check for overflows, and it's a bit annoying. It has a bit of verbosity, and it'd be nice to just kind of like catch a panic instead, as kind of bad as that is. But I think it's like pretty tricky to like kind of detect when overflows are happening, especially if you're like just adding things to numbers and just kind of like trying to be efficient and have like clean code. But I also don't like see a downside to adding these. Like I don't know how they would be abused in some way that's like, oh no, that's like gonna be such a problem. And I think if it does make writing code in some of these, for like encoders or decoders or whatever other circumstances people have, it makes it easier to write that code and write that code safer, which I think is important. Then I think that's worth adding to the language for, right? I think like Go is one of those languages that's like, okay, well, we're safer than C. And this could be one of those things that's like, this is a way in which we are safer than C.
Right. Yeah, because when it overflows, it does so silently, doesn't it? I mean, it's essentially, if there's no error and it just wraps around, you wouldn't know it's happened. And of course that, is a problem.
That is a problem, yeah.
Yeah, I would even say that, so I like this idea. I like both of these proposals in that they handle overflows in some way because Go doesn't have a good way to deal with those.
You can't have them both though, can you?
Well, right, yeah.
You have to pick one.
Right. So what I'm thinking is, so for example, with this proposal, you would still have to check for overflows because if you don't, your code would panic and that might not be the best idea. But the thing is, it would be a safety net of sorts. It's kind of like in Go, there are no buffer overflows because yes, you can check against them, but if you forget to check them, you get a panic. It's not like you execute arbitrary code or you hang forever or that kind of thing. So to me, this proposal feels quite Go-like, but at the same time, what I don't like is that they're separate types. So the user has to choose every single time which one to use. And I think the default should be the safe version. It shouldn't be the weird, funky version that wraps around.
That would be a backwards incompatible change though, I suppose, wouldn't it? Maybe. Maybe not, because is overflowing kind of unspecified behavior, or would there be people that rely on it?
It is specified to wrap around in the Go spec. But the thing is, does much code actually depend on that? And if they do, this could be triggered by like a new Go language version. So if your Go mod says Go when 17 or later, then suddenly ints and uints, they're all, safe against overflow. And then if you do that upgrade and you want the overflow, you use the other type that explicitly allows you to overflow without panicking.
Okay, so you would have another type, but you'd flip it so that the new type had the old behavior and the default behavior was panicking overflows.
Because otherwise you have to trust that people will use this safer type. And I don't think that's a good idea, especially with the amount of existing code.
Yeah. That was a fair point, wasn't it, Johnny? That last point Daniel made. What do you think?
I think it's fair to say it was fair.
Yeah. Oh, so I've made a fair point too. I wondered because I'm trying to see if it's actually time for our regular slot, Unpopular Opinions.
I actually think you should probably leave.
Okay. Who's going to kick us off? Does anyone have an unpopular opinion?
Well, now that you bring it up,
Mm-hmm.
Daniel,
You don't like him?
you see, like usually when we have you on the show, you have one of those faces, one of those voices that is soothing to me, right? Like it's a good thing, right? But you said something earlier that I want you to explain a little bit more about why channels are a foot gun in Go.
What did he say?
He said channels are a foot gun.
Yeah, we're talking about ranging, and I said that people use channels for ranges as a sort of iterator, and I said I think channels are probably the biggest foot gun in Go, and I think that's what probably triggered every action.
He certainly did that. He's livid. What's the phrase you're using?
As my unpopular opinion, you mean?
No, the food gun you were saying, right?
Foot gun.
Yeah, tell us, what's that? What's that about? Can someone explain that for anyone who's never heard it before?
Oh.
It's basically like if you have, a gun, it's, usually you're trying to shoot other things with it, but instead, it's going to hit you in the foot, and that's bad.
Oh, foot gun.
Yeah.
I thought you were saying
What did you think we were saying? Food gun?
I thought you were saying food gun.
Like I'm gonna launch a burger straight at your mouth or something?
I couldn't figure out if it shot food out or if you used it for shooting food.
I'm gonna shoot up some food in the range today.
Yeah.
Oh, man.
Yeah. This is, I mean, you want a language proposal? I propose that our American cousins pronounce their T's a little more and then wouldn't get in this mess. That's a language proposal from me. And then I'm going to actually open that. Can you open PRs for America?
Oh, man.
Okay, Daniel, do you have a real unpopular opinion?
Yeah, I guess so. My unpopular opinion is that Go as a language should be frozen again at some point over the next few years. We've had a couple of years where new features have been added in, especially big ones are being considered like generics. I want to see that slow down again, like it was for like 6 or 7 years after Go 1.0 came out.
You're like, yeah, you've had your fun. You've gone too far. It's time to take a step back. Why?
It's a mix of reasons. On one hand, I feel like Go succeeded the most when it was stable. A lot of the amazing software that came out in Go was conceived while Go was essentially frozen as a language. Mm-hmm. And I feel like if Go keeps growing and growing, it's not like it's growing very fast at the moment, but if it keeps the upward pace like that, I feel like it might lose this good quality of just, being chill and letting other languages experiment and then just taking the good bits and being a small language.
Interesting. Well, what do you think of that, Chris?
I think that's popular. I think that's a something I would like to see. I feel like, especially over the last couple of years, we've had some... I don't think they're missteps, but I feel like we've been moving a little bit too fast with like the sense of urgency. I think modules is a pretty decent example of that. I feel like the end result has been good. I think there was a need, but I feel like there was a lot of stuff with modules that was like, oh, how are we actually going to make this work? How are we going to get the tooling to be there for modules? I mean, I think the tooling's pretty solid, but there were a few really rough years of like, what does my editor install look like? How do I operate in both modules and with GoPath? How do I kind of make both of these two worlds that need to exist for various reasons actually work? I think that, slowing down some, letting other people experiment for a bit and really stabilizing the language would be a good idea.
I think the main reason why this opinion might be unpopular is because it means that a lot of the proposals that people have filed for the language might not make it. Because if we stop at some point for another 5 years or so, that means the proposals are going to keep coming in, but they're either going to be rejected or, put on hold, which might be frustrating for some.
Right. Well, good strong point now, and we'll certainly be testing that unpopular opinion on our Twitter feed at GoTimeFM. And we actually do a poll and find out if it is indeed unpopular or not. Does anybody else have an unpopular opinion?
I have, I guess, a somewhat related one to what Daniel said.
Is it unpopular? Because that's all I care about.
I think so.
Right. Well, then proceed.
I don't think we're ever going to fix the V2 plus module problem in the language. Like, I think we're stuck with that.
Get over it.
Because I think I think anyone that's experienced like a package or a module that has like a V5 version, but also at one point had was like a Go path or like incompatible, and now they're like just trying to import it, and like the tooling's just like, oh, of course you meant like V1, not V5, which is the latest. I think we might find ways to like make that a little bit less rough, but I think that's an inherent design flaw in how semantic import versioning was constructed, and I think we're just more or less stuck with it at this point.
I saw a very popular project on ORM, actually, GORM. Their approach was to basically say, you know what, the old code base, the supposed version 1 of this thing, we're going to move that into a separate branch altogether. Like basically, they just skirted the issue altogether by basically saying, hey, when you pull, right, our V1 now, so whatever our V2, our new features and everything else that was supposed to be V2, we're not going to put that behind a /V2, module path, right? It's that now when you pull it down, that's what you're getting, right? So they basically skirted the whole issue by basically saying the latest stuff is the V1 now. And then they just say, if you want the other stuff, then lock to a commit hash or something, find another way to do it, right? So honestly, I think that's a nice way, right, to actually get around the problem. Although it may rub some people the wrong way, but I think that was a nice way of actually getting around the problem rather than introducing a V2 in the path.
It's a bit of work for maintainers because suddenly they might build their code one day and it doesn't build because they've made breaking changes, but with the relatively simple fix, which is just change your imports or fix your Go mod or whatever. Interesting approach. Has anyone got any views on that?
I think semantic import versioning had to happen because otherwise it wouldn't be impossible to have semantic versioning work at large scale. Because, for example, with the GORM case, if I depend on one library that wants an old version and I depend on another library that wants a newer version, if both are the same version 1 module, there's a clash. There's like a diamond dependency problem. I can't build with both versions at the same time because they're the same module. So that's what version 2 plus is meant to fix. You can build with version 1 and 2 at the same time. But I kind of see Chris's point. We are kind of stuck with this, version 0 and 1 are special problem. But I think it's mostly going to get better with better tooling like package site. So package site, for example, now, if you look at the docs for version 1 and version 3 is the latest stable, it tells you, hey, did you notice that you're not on the latest version? And that's kind of the hint that users should be getting moving forward.
Nice. And by the way, for anyone who doesn't know, a diamond dependency thing is not good. It sounds good. It's not.
Shiny and expensive.
Sounds like you've unlocked an achievement. Yeah. It's like, bring, congratulations, achievement unlocked. You've got a diamond dependency problem. Although it'd be cool if it was like that.
I also feel like for the next couple of years, it's going to be rough on people that were already on V2 when it was like kind of like using DEP or using some other system. And now they're like, I want to upgrade to modules. And it's like, you have to go rewrite your entire, like you can do it automatically, but you have to go to every single import path in your entire code base and update them. And that can be a lift for some people for sure. That's like a big change, especially if you have like a monolith of some sort. Like it can be difficult. I have a friend that has this like exact problem at work, and he's just like, I'm just hanging on to GoPath for dear life until it is very, very dead and gone, and we have to deal with modules, and it's going to be a lift because they've tried to do the upgrade, and it just like didn't work out well for them. So, and maybe there's something we can do to alleviate that, but I think that's also going to be like a struggle for some people.
Brilliant. Anyone want to say anything else? So I'm just going to wind up. I don't know why I say that. Hopefully that gets cut out. It's this silly thing for me to announce on it. Plus this is live, so. Sometimes we go meta, don't we? And we talk about what we're talking about instead of just talking about the thing we're meant to be talking about. I do anyway. This is one of those times. It's time to say goodbye, I'm afraid. I really hope you enjoyed going through these proposals with us. There's actually so many more. Daniel, you'll have to come back very soon and we'll do a part 2 of this episode and talk about some more proposals to the Go language. I'd also love if we could find some kind of bonkers ones. I don't want to be mean to anyone. Definitely not. But I'd love to see some that are like really out there as well. If we could find some of those. If anyone knows of any, please send them in on a stamped address envelope or postcard or some whatever they used to do in the olden days.
Bonkers? You mean like generics? Oh, sorry. Sorry, I'm just yanking your chain.
That was great. No, that's going in there. That one's definitely going to be made into a wrap or put into some sample somewhere. Hopefully. Thank you so much to our guests, Johnny Borsico. Goodbye, Johnny. Have a lovely time.
Live long and prosper. I can't do it. Yeah,
Can't do it. Are there like Vulcan kids that can't do that? And they're like, oh, and it's like there's like a stigma about it and stuff. And they're like, oh, live long and prosper. Do you know what I mean? Daniel, can you do that?
Apparently.
Chris?
You never tried. You got it on the first try. Man, that is
skills. You got 2.
I'm just not using my hands enough, I guess.
Not using it for that enough. Yeah.
Keep it right there.
To be fair, though, that isn't very useful in any other... Like, that's not... You can't even use it for digging. Do you know what I mean? It's nothing. So it's only for that. Showing off that you like Star Trek, or at least are aware of it. Chris, thanks so much again. It was lovely to have you as usual.
Of course.
See you soon. And Daniel Marty. Daniel, see you next time.
Thank you. It was fun.
Thanks, everyone. See you next time. Said it twice. Ridiculous. It's really hard to just basic things sometimes. What I do is just say goodbye in a way that I haven't just said those words.
Now it's time to say goodbye.
Goodbye, everyone. See you next time.
You can support our work and help ensure that GoTime continues into the future with a Changelog++ membership. Ditch the ads, get closer to the metal, and directly contribute to all Changelog podcasts at changelog.com/++. Once again, that's changelog.com/++. Check it out. This episode was hosted by Matt Ryer. It was produced by Jared Santo with music by the Beat Freak, Breakmaster Cylinder. GoTime is brought to you by our awesome sponsors. Special thanks to Fastly, Launch Darkly, and Linode. On the next episode, Johnny and Chris are joined by Ian Lopshire and yours truly to discuss reading the docs. Stay tuned for that one. It'll be hitting your podcast feed next week.
We're doing a sea shanty today, right? No? I thought we're doing... have you not all prepared the sea shanty bits? Oh, we won't do it then.
Those in the show notes.
You're like Anchorman. You only do what's in the show notes.